Okay, so we just got finished talking about this concept of transmittance and percent transmittance. And this is how the field first got started because we didn't know any better, quite honestly. So in the beginning, these machines would measure the transmittance of light. How much came through without any sample in it at all, and then how much came through when I put a sample in it. And then I took those two values and divided them, multiplied by 100, and that gave me percent transmittance. 100% transmittance means that all the light comes through. 0% transmittance basically means no light comes through the instrument, period. It's blocked everything. And then we said, okay, well, that's great, and that's nice to know, but we don't really use transmittance anymore to make measurements. We use absorbance now to make measurements with. So that's what we want to focus on in this video. We want to focus on this concept of absorbance and what it means. Okay, so let's not waste any time and go directly to absorbance. Absorbance is abbreviated as ABS a lot of times in a laboratory. If they get lazy and don't want to write ABS, a lot of times they'll just write the letter A, and that can represent absorbance as well. The problem with percent transmittance. Percent T, we said, was non-linear. Okay? And when something's non-linear, we said that gives us a problem in the data analysis. And if you're unsure what I mean by that, that's okay. We'll talk about it when we get to the data analysis portion. But non-linearity is bad. We want things to make straight lines. So percent transmittance is not going to do it for us. Okay? So the concept is still the same. The concept, we have a light bulb. That light bulb shines light onto a sample holder. That sample does something with the light, and part of it comes through, and then that's seen by the detector on the other end, right? Okay, so that's what begins to happen in the sample and in the machine. Transmittance, we said, is the original light that goes through with no sample in it, and the sample that goes through when something, or the light that goes through when we put a sample in it. Absorbance is a different take on it. You often hear the old saying, the cup half full and the cup half empty. It's all about the point of view. We've got two different points of view here. One is transmittance, that's the cup half full. The other one's absorbance, that's the cup half empty. And we found out that absorbance is better to look at. Okay, so instead of looking at the incoming light and the outgoing light, what we do is that we look at absorbance, and that absorbance basically means how much light is the sample absorbing or eating. So here's the comparison for you. If absorbance is how much light the sample is eating, then transmittance is how much food the sample is leaving behind. Two different perspectives here, right? If this molecule is going down the buffet line and it's picking out what it likes, there's quite a bit of food that's left over. Transmittance is looking at all of that food that's left over, and it's saying, gosh, we've got a lot of food that's left over for everybody else. That is one point of perspective that somebody would have at a buffet line. However, the other point of perspective, and in this case absorbance, the molecule's walking down the buffet line and it's picking out what it likes and it's putting it on its plate. And that point of view would be like, gosh, look at all of that food on that plate that that person is eating. How are they ever going to eat all of that? And are they going to come back for seconds? That's the other point of perspective here. So absorbance is the concept that these molecules are absorbing and eating the light that we're giving them. And that is what the ABS value represents. A little bit different than transmittance, but they're very similar. Again, cup half full, cup half empty. How much food are you leaving behind, and how much food are you going to eat? Those are the two different perspectives that we have here. Well, there's a relationship, right? There's a relationship with the buffet line. There's a relationship with the half empty, half full. There's a relationship with transmittance and absorbance. What is that relationship? Well, if I take the transmittance, whatever that transmittance value is, if I take the transmittance and I log that number and I put a negative out in front, that will allow me to calculate the absorbance value. So very early on, in the beginning, we had instrumentation that would give us the transmittance value. And we would have to sit down with these numbers and we would have to negative log every single one of them. Every one of them we would have to negative log all the way down. And then we would convert all of the transmittance numbers into absorbance numbers. And then we would do our data analysis with absorbance. So we needed a calculator to do these problems. However, nowadays, in a laboratory, don't have to do that. What happens now is that there is a setting. And the setting on the instrument will flip it back and forth between percent transmittance and absorbance. I just have to go in there and I just have to make sure I'm reading under the right unit. By default, absorbance is now set on the machines. No longer do I have to do this calculation anymore. The machine does that calculation for me, and the machine will pop out that number on the computer screen. So again, you need to appreciate all the work that the equipment is doing for you, because if it didn't, you would have to sit down and you would have to do these calculations on your own. So now when I put my sample in and I close my lid and I tell it to scan and I get this number and I go to a go-to feature and it pops out a value on the computer screen, that value by default is absorbance value. It's looking at how much food is on the plate of that molecule. How much of it is it eating? That is the magic number that we need to measure and do our data analysis with. Okay? We can switch it over to percent transmittance like they did in old school days, and we can do measurements in percent transmittance like they did in old school days, but it's no longer done. So if we want to just do it just to do it, we can switch it over with the flip of a button. That's all that it takes. And the numbers will begin to be popped out in percent transmittance on me, but not in absorbance. Be careful if you're asked to use this equation on a test or on an exam, hint, hint, then it will go through and it will make you convert your percentages over to a decimal. All right? So notice this is log of t, not log of percent t. So let's say that my instrument is giving me a percent t value of 65%. Okay, I need to convert that over to a decimal. So move your decimal over 2 times. Divide by 100, right? So 65 divided by 100, 0.65. It's the 0.65 that gets used in this equation. So the absorbance value here will be the negative log of 0.65. And let's see if I've got a calculator. I bet I do. I'll do it right here on the screen for you. You don't even have to bring out your own. So here's the calculator. 0.65, and I need to log that number, and there it is. And then this negative out in front means you take the opposite of. So that basically means that I'm going to look at this number as negative 0.187, and I just take the negative of negative 0.187, and it changes into a positive number. So my absorbance value here would be 0.187. That is how I would calculate absorbance values from percent t numbers. Okay? So this gives us a little bit of insight about absorbance and transmittance. So therefore, on the spectrum, when I began to scan these samples in the beginning, I told you that there's 2 things that are happening here. One of these is the Lambda Max. This is telling me my preferred food item from the buffet, or the preferred lambda from the buffet of electromagnetic spectrum. Well, over here on the y-axis, what is that unit? That unit is absorbance. How much food is it putting on its plate? So the way that you need to regard this is I'm going down the buffet aisle, and I really like the soup beans that they put on that buffet line. So that is my Lambda Max. So I'm going to get a bowl, and I'm going to fill it full to the rim with soup beans, pinto beans. So that is my absorbance value. It's telling me what the favorite is, and at that favorite, how much is going on. And that is the absorbance value that's popped out of the machine. These absorbance values have proper ranges. The plates can only hold so much food before they begin to topple over. We don't like it when compounds have too much food on their plate. So the working range of the absorbance values, those ranges go from about 0.1 all the way to 1.5 absorbance. Those are my absorbance values that I would really like to see on a spectrum. If it is lower than 0.1, that means that they shouldn't be really using a plate. And that also means that my compound is too weak. If the absorbance is higher than 1.5, that means they need a couple of plates to get that food back to the table. But that also means that my compound is way too strong. I need to make it weaker to properly analyze it on a UV spectrometer. So in the next video, we'll talk about how we can ensure that our samples are working or will be running within this range of 0.1 to 1.5. If I have to make these samples, I want to make sure I'm not wasting my time, and I want to make sure that I can get it within that working range of absorbance numbers. So stay tuned. I'm going to tell you how to prepare these samples in just a second.